This talk is called How to Fail at Background Jobs. And the slides are right there so you can skip ahead and cheat. I think that failure is really interesting and we learn a lot from failure. Like the guy that was just talking said about introduce the pain before the solution. I felt a lot of pain and maybe a few solutions. Mostly I want to talk about pain, I think. But I was talking about all the things that I could be talking about in this talk to my good coworker Evan, who's sitting back there. And he was like, oh, so you want to talk about how to fail at background jobs? Well, the answer is simple, right? Delay job. That's how you fail at background. Did anybody use delay job? Have in the past? Anybody still using it? Sorry. Go talk to Evan, find out why you shouldn't be using delay job. Basically, Evan works in support. He works with lots of engineered customers. And many times he sees problems with the database performance. It relates to a customer using delay job that's hammering their database. So if you happen to be using delay job or be considering using delay job, you might want to look at this other alternative similar thing that requires Postgres written by Heroku guy there. And that's it. That's my talk. Engineers having a conference in August called Distill, and you should all submit to the CFP. You could probably give a better talk than that I just gave. I still have time, huh? Yeah? Okay. I guess I'll continue then. So maybe the talk I really want to give isn't, well, we're definitely going to get some failure, but maybe a lesson we can get out of this is abstractions. So I'm going to give a talk about seeking better abstractions for background jobs. I think my current working theory is that the reason I fail so much is because the abstractions are wrong or fail me, or I need better ones. So speaking of abstractions, let's talk about Rails 4 queuing. How many people have heard about the Rails 4 queue system, or the queue system in Rails 4? How many people have heard that that is not going to be in Rails 4? Okay, so you already know then. If you didn't know or you're interested more, you can go to this commit message, or this commit on GitHub and read all the comments about why it was pulled out. I'm going to attempt to summarize some of the reasons why it was pulled out and draw some conclusions on my own about what about it was a fail. So first of all, the API for the Rails 4 queuing system as it stood. One of the commenters points out that the biggest problem with this API is the fact that the name of the queue that you're putting jobs into is defined at the place where you call the push, as opposed to being defined in the job class. Actually, I should probably just explain this API straight up. So the API says you create any object you want, and it has a run method. And the contract is you put that object, push that object onto some queue, and then later on somebody else can pull it off and call run and run your job. And so the problem I see with this is that the arguments to your job, all the data that's needed to reconstruct that object is not part of this contract, right? Somehow it's in this object, and you're going to have to serialize this object and deserialize it. And given this API, what they ended up having to do was use Marshal. And if you've ever tried to marshal an active record object, you'll see something like this. And this isn't great for debugging things in production. But more so, it's very limiting to marshal things. And Marshal itself is prone to problems about, well, marshaling something deep down. You might find a proc, you might have circular references. And you might marshal way too much. You have this massive amount of data in your queue system that's completely unnecessary, right? So I think that's a fail too. Finally, they alluded at the fact that they solved a completely wrong problem. Don't look at this code yet. Look at this code in a second. One of the main use cases I could see in Rails 4 for the queuing system was to send emails. Action Mailer is part of Rails. You send emails with Rails. But when you send an email, you don't want it to interfere with the request processing, right? If you sent an email from a controller action, which might be the simplest thing to do, then that could take some time to send that email before you continue to process your response, and that would slow down the request, right? That's actually I should mention that. One of the main reasons background job systems exist is so that you can do things that you might want to do in request or might want to do as a result of request without interfering with the processing of that request. So to that end, what they said is they really want changes to rack. They want you to not have to run a separate system or a separate job processor for simple things like sending email. They just want that email send to happen after the request goes to the browser, but before you're done processing the request, right? So here's a terrible, evil way to hack rack to make it do this. Right? Rack expects expects a triplet of status, header, and body. So we can make a proxy object around that body and then implement our each to return the real body. And then the last thing we do is actually send the email. And because we set content length, the browser will think we're done and not be blocked on this extra work we're doing. But somehow we'll have to figure out how to get this into rack. And so I took these problems to thought and thought, well, maybe I can help. Maybe what they say is something we can fix. So I tried these pull requests, and it looks like really they're going to rewrite this in Rails 4.1. I don't expect it to look anything like this when they're done. So moving on. Let's tell a story. Back in 2009, I was working at a company called 3M. This was our product. It's a Lava COS chairside oral scanner. And I was writing a Rails app, Rails 2.3, or Rails 2 something. And basically what that Rails app was, it was a glorified file server. And so files would get uploaded from these devices in the wild, and we'd organize them and do things with them. And the state of the art at the time for doing background processing, we Googled this because we had a use case of we're going to copy some files for something, right? And that's going to come from a web request. We already have the files in one place and move them somewhere else. So that needs to happen in the background, not in the request. So state of the art at the time, from what we could tell, was this queue called Starling. Anybody use that? Still use that? Workling. Anybody still use Workling? He's the only guy. He just randomly found you earlier. So these were queue systems. This is how Workling looks when you use it. You create a class of your worker class, represents some work that you want to do. You define a method that does that work. You call async underscore that method with the arguments that are then going to be used to do that work. You can set up the backend system. So this dispatcher equals line is setting up to talk to Starling. And you can configure Starling pretty easily, and you just call run, and you got a worker. So this is cool. We used this for a while. And then we started reading the Twitter engineering blog. And this is around the time that people were saying Rails can't scale because Twitter's not scaling. And we also were concerned about our ability to be distributed and highly available and have a version of this thing running in Europe. So we decided to do the Eric Redmond thing and use some Erlang. RabbitMQ was pretty popular, seemed to be getting popularity. So we're like, all right, we're going to keep using Workling. We're just going to move from Starling to RabbitMQ as the backend system, because this runs on multiple nodes. They replicate each other. If one goes down, you still have a queue system that's working. You didn't lose anything. Has all these other benefits. And the protocol that RabbitMQ speaks is called AMQP. So I'm not going to explain this exactly, but this is some code for speaking AMQP. It's slightly more complicated than the simple push and pop that you get with Starling. Those are two libraries for using AMQP, if you're interested. And then some nice guy, before the existence of GitHub, on some SVN repository had written this AMQP exchange runner for Workling. So all we had to do was swap out our Starling runner for our AMQP runner, and we thought we'd be good to go. Had a little bug. Wasn't exactly related to Rabbit. It was actually related to the fact that Rabbit was faster than Starling. So this is what we started getting. Active record not found. And that's because we were enqueuing jobs in after create blocks. And the funny thing about after create is that it is after your object is created. Y'all familiar with Rails, record, act create. It is after your model is created in the database, but it's not after the transaction to the database that was creating that object completes. So to create an object in the database, there's two lines: insert and then commit. So the insert happened. We enqueue the job. Rabbit's like an open socket to our workers have an open socket to Rabbit, so there's not even polling. It just immediately goes right into the worker, picks it up. OK, let me go to the database. Let me find that object. Let me do some work. It's not there. So you can see the hack fix commented out here, sleep 1. But the other hack fix was this plugin that we wrote. It's old. I don't use it anymore. It's Rails 2.3 only, but it's interesting, maybe. Does somebody do something like this? Because I don't know how to solve this, other than just not doing after creates or after saves. Rescue retry. So what this does is it monkey patches the current connection object, like finding it, opening up the class, instance evaling in, this method chaining, so that you can run this block of code upon execute of commit. Clever. Useful. Maybe. So that was cool. But then we had some more bugs. And maybe these weren't just bugs. It developed itself into this fundamental flaw. See, what we wanted to do is we wanted to use the power of RabbitMQP. We wanted to start actually using the tool underneath of Workling to the extent that it can be used, right? We actually had several apps, and we were like, oh, let's send messages between those apps. And Workling was getting on our way because it was a very simple abstraction. The abstraction for Workling assumed that you have your Rails app accepting requests, and you have your workers processing background jobs, and that's all you need to do, right? It didn't even let you specify names of queues. It was and so we started hacking this stuff in and just decided to throw it away eventually and write our own wrapper that was like Workling because it had a runner and stuff. I don't understand why this didn't exist, by the way, but we wrote it. I think we're the only ones that ever used it. And it's very similar. You say who you subscribe to as a queue name, and then you can notify to that named queue. And then this will work like if we share the Rabbit with two apps, then suddenly you could have background jobs in one app that are actually running due to messages that were notified by the first app. So that's kind of cool. Can't do that in Rescue. OK, let's reflect on this for a second. So what did we learn? Workling failed us. Well, I mean, it worked for a while. But it failed to give us an abstraction that would go the distance. And we failed to open source, too, I guess, because we never did anything. Let's move on. My next job, my current job at Engine Yard, I have to thank Engine Yard, by the way, for sending me here to speak to you lovely people. We're not a train company, but we use Rescue a lot. And our primary use case for Rescue and background jobs in general is to boot a server on Amazon EC2. So let me walk through this code a little bit to give you a sense of the type of thing we're doing here. So we've created an instance as a server, some server that some customer wants. We've created that in our database already. And we have a job here to boot that instance. So we go find it. We create this fog. Fog's a great library for talking to Amazon object. We make the create call to Amazon. We save off the Amazon ID. And then we poll Amazon to see if that server is up. Now, by the way, this code is terrible. All the code that I'm posting is terrible. It's all just for example purposes. Don't copy my code, copy my ideas. No, maybe don't even copy my ideas. Anyway, we wait for that server to be ready, and then we move on to the next thing, which is attaching an IP. And it actually goes on for quite a while, doing all the things that are necessary to set this server up. So this job was kind of ugly, and I was talking to some coworkers about ways that we could refactor this sort of behavior. One direction that you could go in would be to kind of do what we did at 3M, or did for some kinds of jobs at 3M, which is to think about what it would be like if we ran this job in an entirely separate system from the place that enqueued it. So in order for that to happen, obviously we don't want to share databases. I know nobody here does that, right? So what we would need is a way to get all the information that we want sent with with the arguments to that job, not just some ID that we would look it up. So we have extra arguments to our perform method, and then we'd have to have maybe some callbacks that we have this API to where we get to key points in our job to call back to update the customer on what's going on. We never actually implemented anything like this. Of course, you could also go in the complete opposite direction. You could say that background jobs don't actually need to have all of that logic defined inside of the background job, right? Just because the API says class with a perform method and logic inside of it doesn't mean that you need to put all of that logic into perform method. You can put that logic somewhere else. What if we create a job called method calling, and that's the only job we need, and anytime we need to do anything in the background, we'll just enqueue the method calling job with the active record object we want to call the method on and the name of the method. We actually did this for some jobs. The downside being that now when you go and look at what jobs am I running, they're just all method calling jobs. You don't have any insight. And you don't have the other niceties. But along those lines, I recently wrote this library called async, which has this clever DSL for calling async run a method on an active record object later. And it has a pluggable backends concept. So you could use any backend you want, because actually they're all very similar. It's just very slight changes to support Resque and Sidekick and Q. OK, anyway, so refactorings aside, we had a problem with this instance provisioning job. Our customers had a problem. They would sometimes be doing things, and they would get this. They would get some, like, their instances are spinning, some waiting status. It's really stale, old, nothing ever happening to their instances. We would go into Resque Web, which is the web interface for Resque that tells you what's going on. And we see things like jobs running for the last 8 hours, 157 workers. I don't think that's the configured number of workers that we wanted. That could be because some workers died and were replaced and that count didn't decrement, or because some workers are hung, or like, who knows? And what I realized, or what I started to realize, was that there's a difference in the types of reliability that our queue system can have, or that our background jobs processing system might have. At 3M, with AMQP, we thought we were having a reliable system because we used RabbitMQ, and it had these acknowledgments, and it had these durable queues and durable messages concepts. And we're like, well, if a Rabbit node goes down, the queue's still there. But we didn't consider all the problems that the worker processors themselves could have. Right? So there's a difference. So for example, you could have a guarantee that this job's going to be delivered, and if it's not acknowledged, it'll be delivered somewhere else. But what if the job is like halfway done processing and then crashes? Or is almost all the way done processing and then crashes, and you don't get that acknowledgement, and then you run it twice? Maybe that doesn't work. And then there's the concept of retrying. A lot of libraries for background jobs will give you simple retry logic, like if you actually raise an exception, it'll retry. But if your Ruby process crashes for some reason, maybe it won't be retried. Or if you have a hang, maybe you'll need a timeout or some method of timing out. Maybe your timeout won't fire because your process is really hung. We actually had problems like this because we opened sockets and SSH connections to places from our background jobs. And then the remote end disappears, and Ruby doesn't know to close it. We have the problem of monitoring and maintaining some set of workers, right? We want to keep the pool at a certain number. And we want a graceful restart. If it's time we deploy code multiple times a day, we deploy new code, we want our unicorn workers bounce. We want our background job workers to bounce too and pick up that new code, right? But you don't want to interrupt a job that's running. So you need to tell the workers to finish the job you're doing and then shut down and then spin up a new one. And unicorn is cool because it has 60-second built-in request timeout, so you only need to wait 60 seconds. But who knows how long your jobs are going to run, or whatever job is currently running inside of your worker. And then on top of that, you have all this problem of, well, with all these problems comes the problem of not knowing. Like, oh, if a job failed, or a thing that you're expected to happen didn't happen, and you know a job is involved, is that because the job was never enqueued in the first place? Is that because the job failed somewhere? How did it fail? Where in this code path did it fail? So having all these problems, I tried to tackle the most simple or the most logical one first, which is figuring out what's going on. So I wrote this Resque plugin because there's 200 Resque plugins on Ruby gems. So clearly that's how you do things in Resque. You write plugins. So you can try this out. It's kind of OK. You include it in your job, and you define a track method. And what that does is it lets you extract these identifiers to objects that are relevant to the job you're running. So for an instance provision job, the relevant objects are the instance and also the account which customer owns this instance, and maybe other things. And this will hit this during enqueue and during run and keep up to date what jobs are going on. And then after the fact or during the fact, you can go and call methods like this, where you go look up, are there any jobs currently running of any sort that might be affecting this customer or this instance, or are there any jobs that failed in the past 24 hours? Because you know the thing about Redis is everything you put in there you should expire, because that's what's awesome about Redis, right? Just put temporary data in there, tracking data. That kind of helped a little bit. I was probably the only person that really used that to debug problems. Bigger problem that we had. Other problem that we had. Dependencies. So one of the things you might do as an engineered customer is add a database replica to your cluster. And since we like making code in nice concrete blocks instead of monolithic methods, we break this out into several jobs. You create a database replica. That means we need another job to snapshot the database master. We reuse that job that snapshots the database master. And when that job finishes, we're going to need to provision a volume. That's like the disk that's going to run. That's from that copy of the database master. And before we can do anything after that, we're going to have to wait for the snapshot to complete. And then there's going to be these callbacks that like re-enqueue those jobs to make sure this happens. And that was a big mess. So why not write another Resque plugin? This one's much crazier than job tracking. Never got used in production. But I thought it was super clever. So what this does, this example here, is it's depending on other jobs. So we'll run the sandwich job with these arguments. And we'll see that the first step is that we need to fetch a tomato. So we'll depend on the tomato job, pass it the argument from this job, and continue on. And we'll see that slicing the tomato depends on the output of the first job. So that step can't run yet. And then when the first job finishes, we'll re-enqueue the sandwich job and proceed to the next step. And then some steps we'll see that they can run simultaneously. So we'll run the sandwich job twice on those steps. And then it'll all come back together and finish. And this solved the problem of expressing the dependencies of the jobs more clearly, but it didn't solve the problem of being able to debug what was going on, because it just put a bunch of shit in Redis. So in desperation, we went back to that job tracking job. By the way, the job tracking plugin depended on this Resque plugin called metadata, which lets you associate random metadata to any job. So we decided, okay, well, it's kind of hard to figure out what's going on by looking in Redis for these failures. What if we put them in a database instead? Then maybe we could figure it out. So we create a rescue job model, and we start hooking into this to create a rescue job object whenever you enqueue a job in Redis. And then when it starts to execute, we'll update that record and so forth, just like the job tracking plugin did. And now we have this active record thing we can do. We can find on this. We can do SQL to figure out what's going on. We can figure out what the most failing job is and how recently it happened. And this kind of hosted our database for a while, and so we turned it off. One of my coworkers, Andy Delcom, gave this talk at Cascadia not too long ago. You can download my slides and click play on this one if you're interested. And his premise was we could solve this tracking dependencies problem by generating unique IDs. So when a customer hits a page that's a web request, we'll generate a unique ID. And then if there's any jobs that get enqueued as a result of that, we'll just use the same unique ID on that. And if any of those jobs enqueue other jobs, we'll use the same unique ID. And then finally, when we get some exception somewhere down in the middle of nowhere, we'll have that ID, and then we'll be able to go back and look, like, we can build this tree of all these jobs that figure it out. He never actually implemented that, but it's still a cool idea. And this guy, this is Josh. He went and solved the problem for me. He called the solution modeling intent. He said that what we needed to do was model what the customer wanted to do with an object in our system. And my interpretation of that in terms of background jobs means creating models that are specific to the task you're performing. Right? So whereas before instance provision was a job that was defined, it'd go in Redis. You could go look at that queue in Redis and see all of them. That would then disappear when it had completed. Now instance provision is an active record object, and it relates to an instance via simple belongs to, and the implementation is very similar, and we could use the method calling job or some similar flavor thereof to actually invoke this thing. But the point is, now we have much better sense of what's going on in our system, right? And we have not solved the problem in an abstract way. We're solving the problem that we have in a way that is specific to the domain. And the important attributes, some of the important attributes that this instance provision object had were things like requested at, started at, finished at, and state. So you could look at the system, look at all of the instance provision jobs for a given account or environment, and know ones that recently finished, ones that are running that haven't finished. You could look at instance terminate jobs and compare them. And now suddenly, our instance provision job could see that an instance terminate is running, so maybe I shouldn't run myself. And before that would have just been this race condition between two jobs, one trying to start a server and the other one trying to shut it down. And having state lets us be idempotent. So everybody knows that this is important when you're writing jobs, right? If you write your jobs in an idempotent way, that means that if you run the job twice, it will not do anything more than if you had ran it just once. A GET request is idempotent because it always returns the same result, whereas a post request is not idempotent because it's potentially modifying something. So making every job idempotent is really powerful, and with a simple lock and some updating of state, we can ensure that the job won't run twice, or if it attempts to run a second time, that it will raise an exception. Additionally, here's a piece of code that my coworker wrote called Viaduct, which is extracted from a project called Vagrant, which you may have heard of. And what Viaduct is it's rack middlewares without rack. So it's this concept of you have a bunch of things to do, and you want them to be wrapped such that the innermost one is wrapped by the outer ones, right? So we could have this generic concept of instrumentation for jobs, and we would use Viaduct to run it. And this wasn't specific to Resque. It wasn't specific to the abstraction that we're using for background jobs. We could just put this inside the implementation of any particular instance provision type of thing. I guess what we learned again is that our abstractions are failing us. Modifying Resque, adding plugins is a fun exercise, and solving the problem in an abstract way is it's like this goal, like, oh, I'm going to do this, I'm going to solve this problem in an abstract way, and then everybody else who has this problem is also going to have that solution because I've solved it abstractly. But in many cases, it's a lot easier, simpler, and better to simply solve exactly the problem you have. So on my latest project, a building project that I've been working on, I thought, well, if I'm really going to learn how these background job systems work and understand anything, I'm going to have to build one myself. All right, so let's distill down the 3 ingredients that it takes to make a background job system. It's peaches, butter, and sugar. It's really delicious on the grill. No, it's actually a work loop, some loop of code that's picking up a job, running it, picking up the next job, running it. Maybe there's polling, maybe it's push to, whatever. It's monitoring and restarting. Anecdote I missed mentioning earlier. So at 3M, I was a developer. There was a separate person that did operations. I thought I was being awesome when I wrote code that would make AMQP fail over to another server if she provided me a list of servers that were running by their host names, right? At Engine Yard, there's no operations because our product is operations. So every Engine Yard developer is operations, and we have DBAs that are really good at databases and some support people that really know Unicorn or this or that. But for the most part, we just use our product. So I got to see what it was really like to monitor background job systems, ensure that they gracefully restart, et cetera. And so now I consider this a major part of building any. And of course, the third ingredient that we'll need is the queue. That's just a place to put jobs so that you can then pop them off. Right? So let's talk about some different loops. This is a rough, some line stripped out version of what the rescue event looks like, or event loop looks like. It's just a loop, as you would expect. There's a nice little hook for before fork. Rescue has this fun behavior of forking off child processes to insulate the parent from failures, and that kind of works in some cases, kind of makes it harder to monitor in other cases. But the thing I don't like about this is it's not, it monopolizes what the worker process is doing, right? You run a rescue worker process, it never exits, it's just running this loop. I can't hook into it very well. What I'd like, in many cases, is event machine. This is event machine's loop. It's written in C++ as a C extension, so it's kind of harder to read, and there's a lot more code that I stripped out to be able to fit it on this slide. But what event machine has is hooks. So you can run if em runs start server is going to run forever, but somewhere inside of there I can call em next tick, and that'll just get stuck into this event machine event loop. And I can say em add timer, do something in this number of time, and that'll get shoved into that loop at some point. So I kind of wish we had something like this for rescue. Then I never actually have used Sidekick in production, but we've tried to move to Sidekick a few times and been prevented by the existence of too many rescue plugins. So I went and tried to figure out how Sidekick works. It's a lot of magic relating to celluloid. Basically, there's these three things: a manager, a fetcher, and a processor. And they are celluloid actors, which means they are threads running on their own. And they're like calling back to each other. So the manager will kick off the fetcher, which will pick up a job, which will call to the processor, which will say, OK, I'm done, and go back to the manager and call the process fetcher and so forth. So that's a cool loop concept because you can just add a new thread in there, and it's just all threads, and it's just like this pool of things running. Next topic, monitor and restart. So take a look at how rescue handles signals and how it handles the restart. The signal we care about for graceful restart with rescue is quit, because that will wait for the current job to finish. The signal that you send when you control C or kill a process is that second one, term or int, so you have to be careful. So we want something like this. And we're going to need a monitoring solution. Most of the rescue deploys we have in production are monitored with God. So we could just SSH into a box and bundle exec rake, rescue work, ampersand, background it like that. But we wanted to daemonize this and have another process monitoring and restart it if it dies and have this logic for restarting it. So he's God. But you could have just used daemons. This is what Workling used. This is what then, therefore, AMQP listener used because I didn't know anything else. And daemons works pretty simply, except for the fact that you have to remember to set all these options to true. It's just one line of, like, this is the file to run. Or maybe you don't need a separate background job process. Anybody use TorqueBox? Or heard of TorqueBox? So I was in South Africa, and this guy with this awesome handstand gave a talk about how his company is using exclusively JRuby. And he talked a lot about background jobs. And he mentioned that TorqueBox, which is built on top of JBoss, is like built on top of this Java stuff, this messaging system, blah, blah, blah. And basically, they don't have worker processes that they have to manage. They just have to manage the restart of their web application server, their TorqueBox. And they could even have some threads that process web request and now process a background job, and it's all like built in together, and they don't have to worry about it. So I was pretty jealous of that. So I kind of wish I had that for rescue. Third ingredient is the queue. Do you guys know who Terrence is? He's a maintainer of rescue, and he's also a maintainer of bundler. And I thought it was interesting that he wrote this code, and he gave a talk about how, this is a very small snippet of this code, but he gave a talk about how the bundler API works. So whenever you bundle, that makes a request to the bundler API to resolve dependencies. That API is fetching data from rubygems.org, and it's not using rescue. So he had a need to use background job processing, and instead he used a thread pool. So and the construct for the queue in this case is the Ruby library object called queue, which is just a thread-safe array, basically, that you can push and pop things or enqueue, dequeue things. You can go read the full source code there. Or we could use a DRB object. And anybody use DRB before? Just a little bit? Let me explain what DRB is. DRB is written in Ruby. Eric's examples could have been written with DRB instead of 0MQ. 0MQ is like the cool version, I guess. But it lets you take an object and start a service on some port that is hosting that object. And then other Ruby processes can go and call methods on that object remotely and get the result like serialized and remarshaled on their side, right? So we can have this service manager object. So I wanted to make a library called Hydra, but that name was taken. So we have multi-headed Greek monster. We create the service manager that has these things that it does, and we can give and take things from there, and that'll be our queue. And actually, this is a cool library because this is what I use when I want to run a migration that affects a lot of records. So you can, because what it'll do is it'll fork off child processes that communicate to the service manager. And so you could do find in batches of some active record model, and it'll pull and feed the monster these batches of things, and then workers will come up and pick them up, and then they'll all close up and finish. And your migration runs faster because it's multi-core, because otherwise Rails doesn't use multiple cores, or Ruby doesn't use multiple cores unless you have a better Ruby implementation. Redis, the most common, popular default queue system. This is a little snippet of code pulled from the queue background processing library. We use rpush and lpop. Those are the canonical methods for putting things in and out of Redis. You all know Redis, right? No? You just don't like raising your hands anymore. And I picked Q because it also has a Mongo backend. So it's kind of like Workling in that, or it kind of tried to revive some of that concept of Workling of, well, we can have multiple backends. And this is what, we had never used Mongo, so I don't even know exactly how this code works. There's an upsert, which I thought was cool, that you put things in a queue with an upsert, and then you pull them out by deleting them. OK, so let's put all this stuff together. Let's make the most simple queue that we can that still works and is production ready. So we're going to have this the script that runs. It requires our Rails environment. I created a loop called trap loop. The whole implementation fits on the next slide, so it's pretty simple. I'll explain it. So I start this trap loop, that's a loop, and I put the call to the work that I'm going to do. So this is a processor that's this whole queue system is just for processing invoices in our billing system. And then we do the daemons thing where we say, this is the file I want to run, and we put in all those options that are important. And then this trap loop, what it does is it lets us do graceful restarts. So start was as our loop object. We said trap loop start, and inside of that do work. And it has the while loop do yield thing, so that's running forever. And then when we get a signal of somebody control-C'ing or killing our process, we hit that stop call, and we save off the fact that our loop should terminate, or loop false. And then loop is now false, and it won't yield anymore, and it'll exit. Additionally, we have this thing called safe exit point. I don't know why this doesn't exist in any other queue system, or how other queue systems solve this. If you know, please tell me. Safe exit point means that I could put somewhere in my invoice processing code places that I'm finished processing something that it's OK for me to stop before I start processing the next thing. And so what that'll do is, like, if I call that and we're not looping, then we can raise. And if we are looping, then we don't do anything because nobody tells us to stop. So finally, the implementation of our invoice processing task. Our use case here is was especially ill-suited to the conventional queuing systems because we actually have two queues. We have a queue of invoices, and then each invoice has a queue of tasks that must be run to process that invoice. And so I actually wanted to be able to, in queue a task, push on both lists, and then pop off the one for process invoices, and then as you process an invoice, pop off the tasks list and so forth. And when you run a task, it may enqueue new tasks. And then I've called save exit point in these convenient places so that I know I won't interrupt my jobs from processing something. And that's it. So let me try to draw some conclusions from my failures. Abstraction awareness. So I think one of the lessons I learned was that it's okay sometimes to create a specific abstraction or solve the problem you're having specific to the problem, as opposed to thinking in the broader global sense of let me solve this generic problem, right? I love doing that. I love coming up with a solution that I'm going to solve everybody who has this class of problems problem, but I don't do that. Model important jobs in your domain. If you're sending an email, you can use a simple job class for that, right? If you're doing something that's critical to your business process that you need to know if it completed, when it completed, what happened if it failed, why it failed, it's going to be a lot easier to track that stuff down if you put that directly in your database and you have a one-to-one relationship between a job that could be running and a record in your database that is the intention of that job. And contribute to Resque, because I want to see these problems solved. I want to see better abstractions out there. I want to see Rails 4 actually solve a lot of the problems that I've had. And it seems like Resque is currently the best place for that type of innovation to happen. There's a lot going on with Resque 2, and there's tons of pull requests being pulled in. And I think whatever comes out of that will feed back into the eventual Rails 4.1 queuing system.